morning to everyone. So today I am taking a class from a university. So yesterday, all the faculty members received the message from the registrar. So from tomorrow onwards, we are going to take the class from home. Okay? So maybe for the next 2 weeks, we are going to take the class from home. Okay, I think there is no issue from my side regarding net issues. Suppose if there is any problem, so immediately send the message to the group, or suppose if sometimes I don't see the WhatsApp when I'm taking class. Otherwise, just you call me, okay, and then I will again reconnect, and then I will take the class. Okay. So last time it was happened when I am taking for the first year. So even this happened in the university. So I'm taking the class, and during the class time, there is some problem. So still I'm taking the class. Finally, students send a message through WhatsApp, and then only I know that, okay. So I'm speaking lonely. So I think you will inform quickly. Okay, now go to the subject. So the last class I started a Newton-Raphson method. Okay, so we solved one problem in Newton-Raphson method. So this is the second problem. So please take your calculator. Okay, so I also take the calculator. So find the negative root of, the question is find the negative root of x cube minus 4x, x cube minus 4x plus 9 equal to 0 by Newton-Raphson method. So instead of finding the negative root, I will find the positive root of this equation, and then finally multiply by minus 1. We will get the negative root of this equation. That is the idea here. Okay, now, okay. So let us take f of x is equal to x cube minus 4x plus 9 equal to 0. So let's take f of x is equal to given polynomial, and then find the f of minus x. F of minus x is equal to minus x whole cube. Instead of x, just replace by minus x. Okay, so minus x whole cube minus 4 into minus x plus 9 equal to 0. Okay, so you'll get minus x cube. So minus into minus plus 4x plus 9 equal to 0. So let us take this polynomial is phi of x. Let's take this polynomial is phi of x. Now I am going to find the positive root of this polynomial, this cubic polynomial. Okay, so I will take this phi of x. Now substitute x is equal to 0. If I substitute x is equal to 0, this is 0, this is 0, 9. So that is a positive number. If we substitute x is equal to 1, we'll get minus 1 plus 4 plus 4 plus 9. So 13 minus 1, 12. Okay, positive. Okay. And then if we substitute x is equal to 2, so minus 8 plus 8 plus 9, you get 9. So again positive. And then substitute x is equal to 3. So 3 cube minus 27 plus 12 plus 9. So 21 minus 6. So there is a change in the sign. There is a change in the sign. Okay, so and hence the roots of phi of x lies between 2 and 3. 2 and 3. Now I am taking the initial approximation is average of these two. That is 2 plus 3 by 2. That is 2.5. Let us take the initial approximation of the positive root is, this is the approximate root I am taking. The initial approximate because x naught. So this is the initial approximate root. I am taking 2.5. Now this is a Newton-Raphson iterative formula. So last class we discussed xn plus 1 equal to xn minus phi of xn divided by phi dash of xn. So okay. So this is the Newton-Raphson formula, iterative formula, where n equal to 0, 1, 2, 3, and so on. Okay. Now what is phi of x? What is phi of x? Phi of x is equal to minus x cubed plus 4x plus 9. Phi of x is equal to minus x cubed plus 4x plus 9. Okay, now phi dash of x is equal to, to differentiate you'll get minus 3x square plus 4. This is phi dash of x. So now this is the iterative formula, xn plus 1 equal to xn, that is a previous iteration value, minus phi of xn divided by phi dash of xn. Okay. So now this is equal to xn minus phi of xn is, instead of x, just replace by xn. So minus xn cube plus 4xn plus 9. That is the numerator. Phi dash of xn. So we know that phi dash of x. So replace x by xn. So minus 3 xn square plus 4. Okay. So once you have up to this level, now you should substitute n equal to 0, 1, 2, 3, and so on. If I substitute n equal to 0 here, so x1 equal to x naught minus x naught cube plus 4x naught plus 9 divided by minus 3x naught square plus 4. Okay, the last class I told that how to calculate using the calculator. Okay, I think everybody know that method. So here you should keep your mode is in radian or not, I think degree mode. Okay, degree mode. So keep it is in degree mode, and then put a bracket, left parenthesis. Okay, so again I will recall, left bracket, you should open the left bracket, and then press the button alpha, which is very near to shift, and then if I need x, okay, instead of x naught I will take x. So now press the button, closing bracket, so you will have x, that is capital X, in your screen. Suppose if you don't have, please tell me, and then put minus, and then put two left to open brackets. Okay, so left to open bracket, you should press 2 times, and then minus alpha button, and then x cube, closing bracket. Okay, x, I think power, you know that. Okay, x cube, and then plus 4 alpha x plus 9, close one bracket, and then divide by again open one bracket, minus 3 alpha closing bracket, x, that is for x square, plus 4. There are three closing brackets. Okay. Now press calc. It will ask x question mark. So put press. I need initial approximation is what, 2.5. If you give 2.5, you will get 2.728813559. You got this value? You got the value 2.728813559?
Yeah, sir.
Okay, thank you. So, okay. So next, similarly check. Next, press calc and then answer and then equal to. So check it. Our x2 equal to x1 minus this expression. So 2.70674949. So please check all these four values. If you don't get it, please tell me. And then again, calc answer equal to 2.7065 or 27977. And then again, calc answer equal to 2.7065 27955. And then again, calc answer equal to 2.7065 27955. I think here in the fourth iteration, the fifth iteration, so the nearly you'll get the same value. So that's why you can stop here. So we get the positive root of phi of x is equal to 0 is 2.7065 27955. So and hence the negative root of f of x equal to 0 is just minus sign multiplied by -1 minus 2.7065 27955. So next problem, find an iterative formula. Find an iterative formula to find the reciprocal of a number. To find a reciprocal of a number n by Newton-Raphson method, and hence obtain 1 by 19. 1 by 19. So what is the question again? I'll read the question. Find an iterative formula to find the reciprocal of a number n. Okay, reciprocal of a number n, and by Newton-Raphson method obtain the value of 1 by 19. So x is equal to, let us take x is equal to reciprocal of what? N, that is 1 by n. Okay, so then n equal to 1 by x. From this I have n minus 1 by x is equal to 0. So assume that f of x is equal to n minus 1 by x. Okay. So this is my f of x, and I need f dash of x. F dash of x is equal to 0. If you differentiate 1 by x, you'll get minus 1 by x square. So minus into minus plus 1 by x square. Okay. I got f dash of x. Okay. Suppose if I take f of x is equal to, instead of writing like this, n equal to 1 by x, suppose if I take x is equal to 1 by n, so suppose if I take f of x is equal to x minus 1 by n, okay, so the difference of these two, then f dash of x is equal to 1, this is 0, okay. Now by Newton-Raphson formula, xn plus 1 equal to xn minus, what is f of xn? F of xn is xn minus 1 by xn divided by f dash of xn is 1. So you can cancel xn and xn. Remaining you have minus of minus 1 by n, 1 by n. So xn plus 1 is 1 by n. So xn is also what? Xn is also 1 by n. Okay, xn plus 1 is also 1 by n. So you don't get an iterative formula. Suppose if you consider f of x is equal to x minus 1 by n, you don't get an iterative formula. So that's why I will write n equal to 1 by x, and then I will take n, the difference between these two, that is n minus 1 by x. I'm taking this is the function of x, and then I am finding f dash of x. F dash of x is equal to 1 by x square. So now, so come to Newton-Raphson formula. Okay, xn plus 1 equal to xn minus f of xn divided by f dash of xn, where n varies from 0, 1, 2, 3, etc. Okay, now xn plus 1. Okay, xn plus 1 equal to xn minus f of xn. What is f of xn? N minus 1 by xn. Okay, f dash of xn is 1 by xn square. Okay, so now from here to here, xn, so 1 by xn square, I will write in the numerator, that is xn square into n minus 1 by xn. Okay, xn multiplied by xn square here, so minus n into xn square, minus into minus plus, xn square divided by xn is xn. Okay, so add these two, we'll get 2xn minus n into xn square. So I'm taking commonly xn. So xn plus 1 equal to xn into 2 minus n into xn. So n varies from 0, 1, 2, 3. So this is an iterative formula. This is an iterative formula for reciprocal of a number n. Okay, this is an iterative formula. Okay. So now using this iterative formula, I'm going to find the value of 1 by 19. Okay. So if you type in the calculator, you will get the answer for 1 by 19. Okay. But using this iterative formula, so we will get the value of 1 by 19. Okay. So find 1 by 19. So let us take n equal to 19. Here n equal to not 1 by 19, n equal to 19. Okay. So the iterative formula is what? Xn plus 1 equal to xn into 2 minus n into xn. Okay. So if you substitute xn plus 1, xn plus 1 equal to xn minus 2, n is 19. Just replace n by 19. Now n varies from 0, 1, 2, 3, etc. Okay. Now I need to substitute n equal to 0. If I substitute n equal to 0, I'll get left hand side is x1, right hand side is what? x0 minus into 2 minus 19 into x0. So I should take some approximative value for 1 by 19. Okay. So that's why I will take 1 by 20 is x0. Okay, 1 by 20 is x0. Okay, that is we know that is 1 by 2 is 0.5. Okay, so 1 by 20 is 0.05. So let us take this value is x0. Okay, so instead of x0, you should substitute the value here. Okay, so here also you should substitute here. So please check whether you are getting these values for x1, for x2, for x3, for x4. So using calculator, please check it, and x3 and x4 are nearly same. Even for the 8 digit, you are getting same values. So that's why I will stop up to 4th iteration, and hence 1 by 19 equal to 0.052631578. Okay. think you can check it even now or later. So we will solve one more problem. Find the positive root of find the positive root of x is equal to cos x. X is equal to cos x using Newton-Raphson method. So now, so let us take f of x is equal to x minus cos x. Then calculate, we need to find the positive root. So that's why I substitute x is equal to 0. So f of 0. So 0 minus cos 0, that is minus 1. So which is negative number. And then f of 1 minus cos 1. So we'll put in radian mode. So what is 1 minus cos 1? Please tell. Calculate.
Minus 0.45969.
Minus or plus? Please check it.
Plus, sir.
Yeah, plus. Yeah, plus 4 point. Sorry.
0.45.
Yeah, 0.45 or 9697. So which is a positive number. So and hence the roots lies between 0 and 1. So you should write here, since f of 0 equals 0, since f of 0 and f of 1 are of opposite sign, so at least one real root must lie between 0 and 1. At least one real root must lie between 0 and 1. Okay. So now, so let us take the initial approximate values, average of 0 and 1. So let us take x naught equal to 0.5. So Newton-Raphson iterative formula. iterative formula is xn plus 1 equal to xn minus f of xn divided by f dash of xn. So n varies from 0, 1, 2, 3, etc. Now, you know that f of x is equal to x minus cos x. Okay, and hence f dash of x is equal to 1 plus sin x. 1 plus sin x. Okay, so and hence the next page I will write. So xn plus 1 equal to xn minus f of xn. F of xn is xn minus cos xn. Xn minus cos xn divided by f dash of xn. F dash of xn is 1 plus sin xn. So n varies from 0, 1, 2, 3, and so on. Now substitute n equal to 0, you get x1 equal to x0 minus x0 cos x0 divided by 1 plus sin x0. Okay, now you know that x0 is 0.5. Okay, 0.5. Substitute here and find the value of x1. So please do it.
Sir,
Please tell.
sir, if you don't mind, once again, can you explain how to do in calculator, sir?
Okay, I will tell. So now here you have cos and sin. So it is better to take in radian mode first. So press the button, mode button, 3 times, I think 4 times. So you have, so degree is 1, radian is 2. Okay, press the button 2 again. So if you press the button, you'll get a radian mode. Okay, now here the right hand side expression is we have x naught, but I will consider instead of x naught in generally x. So first I'm going to press the button left parenthesis, that is just above the number 8 and 9. So adjacent to E and G, that is a left bracket. First I'm going to press the left bracket. Okay, and then I'm going to press X. For this, first you should press the button alpha, which is just near to the button shift. The right hand side of shift you have alpha. So press the button alpha, and then now press the button closing bracket. So that is next to the opening bracket. So if you press the closing bracket, you have symbol X. Okay, if you don't get it, please tell me. Okay, and then put minus sign. Okay, and then open two opening bracket. Open the 2 opening bracket, because here you have the division sign. So if you don't have division sign, 1 bracket is enough. Okay, here I have the division, so that's why I'm opening 2 brackets, and then again press the button alpha, and then press the button closing the bracket. So X, the symbol will appear in your calculator, and then minus cos, I need X, so that's why alpha closing bracket. So X, now close 1 bracket, so closing bracket will come. Okay, and then put the symbol division. Now opening bracket 1 plus sine, I need X, so that's why alpha closing bracket. Now I'll have x. Now close three brackets because okay, we need to close one bracket for this. Remaining two brackets already we opened, so that's why here I closed three brackets. Now everything's over, but now you should press the button calc CALC. Just that is just below to shift. It will ask X question mark. Okay, you need to type the initial approximate value 0.5. Okay, and then press the button equal to. So you will get 0.75. So all of you got this value. Please check it. I got 0.75 22 222 417. Suppose if you don't get it, please tell me. Okay.
Sir, after pressing cal, it is not showing anything, sir.
After pressing calc, it will ask X question mark. It will ask.
Sir, how to change radian mode?
Okay. So again, I will come from the first. Okay. I think the calculator, you have the mode button. Okay. So now press, suppose if you press mode button, you have complex and 1 and 2 symbol. Okay. Okay. Again, press the button. SD, REG, base 1, 2, 3. So next, press the mode. Equation, mat, DCT. That is 1, 2, 3. I don't need that one. And then now you have degree radian. Okay, degree radian. Suppose if you need a degree, you need to press 1. If you need a radian, okay, if you need a radian, press the button 2. Okay, press the button 2. Press the button 2. Okay, now this is the method to get radian mode. Okay, now are you got radian mode?
Yes, sir.
Okay, now again I'll repeat for this expression how to type. So first you should opening the bracket. Okay, so that is just right to ENG button. Okay, that is in the I think you can see the bracket button. Okay, and then I need X instead of X naught, I will just type X. So press the button alpha, and then closing bracket. So the closing bracket will not come, but X will come there. Okay, minus, you have a numerator as well as denominator. Okay, that's why I am opening two opening brackets, so it will visible for you, two opening brackets, and then alpha, closing bracket. Now you will see X minus cos X means I need X, alpha, closing bracket. So you have now minus cos X, close one bracket, division, open one bracket, 1 plus sine, I need X, so again alpha, closing bracket, you will get X. So now you should close three brackets, 1, 2, 3. Okay, now Mahesh Babu, you should press calc button. It will ask X question mark. It is asking or not? No.
Yes, sir, it is asking now.
Now press 0.5 and press equal to. So I got 0.755 222 417. Okay. Now please write. So don't do anything in the calculator. So now x2 equal to x1 minus cos x1 divided by 1 plus sine x1. Okay. Now come to calculator again. Press calc. It will ask X question mark. So you don't give any value. So just to press answer button, ANS. So it will take the previous answer, that is a 0.7552222417, and then press equal to. You will get, please tell your value.
0.739141,666.
141,666. So now x3. So you know how to write this expression. I'll write the directly answer. Again, calc, class x question mark, press answer and equal to. Okay, tell the value. 0.73.
0.739085,133.
So one more iteration, x4. Calc answer equal to 0.739085,133. I think you can see here x3 and x4 are exactly same. So and hence you can stop the iteration here. Okay, so the approximate value of 1/19 equal to, so you should write 0.7. Okay, the approximate value of 1/19 we need to find out, that is equal to 0. Sorry, it's a previous problem. Confused with the previous problem. Okay, we need to find the positive root of x cos x. Okay, x minus cos x. So the positive root of x is equal to cos x is 0.739085,133. So this is the final answer. You should write after this step. You should write. Okay. So I think you know how to do in calculator. So again, I will just suppose if you are comfortable with this operation, you will do it. Okay, I don't compel you. You should learn this. Okay, suppose if you are not comfortable, okay, leave it. So as usual, I should type how you how you will use your calculator, your own method. So type for each expression, because if you done mistake in the first iteration, everything remaining values are wrong. Okay, so that's why if you are very comfortable, then you can use this. Otherwise, find x1, substitute here, again find x2. Okay, it will take time, but you will get the final answer, correct answer. Okay, suppose if you are doing by this method, you should check once again. Okay, so make it sure that whether you done it correctly or not. Okay. Now Newton-Raphson method is over. So here there are enough problem for you practice. So using Newton's formula, Newton's-Raphson method, solve the following equation. This is a polynomial equation. So this is an 4x minus e power x. Okay, x log x minus 1.2. So here x power x is equal to 100. Find the root between 3 and 4. So x tan x is equal to 1.28. X e power x is equal to cos x. So try to solve this problem. So answer is also given here. Okay. Now this is a problem related to the reciprocal of 1/n. Okay, reciprocal of 1/n, and we find the value of 1/19. Similarly, find the iterative formula to find the root n. Okay, root n. So and hence let us take x is equal to root n. X is equal to root n. So f of x is equal to difference between these two, that is x minus root n. So and then you should find f dash of x. Okay, f dash of x. So try to find the iterative formula for root n, and then okay, please write here. Please write. If you do it like this, f dash of x is equal to 1. Dash of x is equal to 1. So you don't you don't get it. Dash of x is equal to 1. So what we can do? So if you square and let's take x is equal to root 10, x is equal to root 10. So x square equal to n. Okay, x square equal to n. Now we will take the difference between these two, x square minus n. So that is the difference. So let us take this is our f of x, and hence f dash of x is equal to 2x. Dash of x is equal to 2x. So what is the iterative formula? Iterative formula is xn plus 1 equal to xn minus f of xn divided by f dash of xn. Okay, so xn, okay, xn minus f of xn is what? F of xn is xn square minus n minus f dash of xn. Minus f dash of xn is 2xn. 2xn. Now simplify. Okay, simplify this one. You will get this answer. Xn plus 1 equal to 1 by 2 into xn plus n by xn. Okay, so you can get it from this easily, and then using this iterative formula you can find root 5. You can find root 5. So you can take x naught is root 4. Okay, there is initial approximate value, you should choose it. So x naught equal to root 4. Root 4 is 2. Okay, and similarly find the iterative formula for to find the cube root of the positive number n. Cube root. Okay, cube root of positive number, that is n power 1 by 3. N power 1 by 3. So here x is equal to root n. Okay, so here x is equal to n power 1 by 3. Here I am both sides squaring here, so I get x square equal to n. Here you should take cube on both sides, x cube equal to n, and then you should take the difference, f of x is equal to x cube minus n, and then find f dash of x. After finding f dash of x, you should use this formula, so you will get the answer, third answer. Okay, and using this iterative formula you should find 24 power 1 by 3, and then in general find the iterative formula for pth root of a positive number n, that is n power 1 by p. N power 1 by p. So let us take x is equal to n power 1 by p. So x power p equal to n. So let us take f of x is equal to x power p minus n. Find the first derivative, f dash of x, that is a p into x power p minus 1, and then use the iterative formula, you will get this answer. So I think you can do it. Suppose if you feel any difficulty, you can contact me.
Sir,
Yeah, please tell.
what could be the value of x naught?
For this one,
Yes, sir.
okay.
And the previous one also, sir.
Previous one. Okay. For this, you can take 25 whole power 1 or cube 1 by 3. What is 25 whole power 1 by 3? Because we should take the known number. Okay, so otherwise you should take x naught is 25 power whole power 1 by 3 using calculator. Okay, you should take, otherwise we don't have any other option, because here you can take easily, that is root 4. Root 4 is 2. Okay, but here you should choose 25 whole power 1 by 3 using calculator. So that is the x naught value. So that is very close to 24 whole power 1 by 3. Okay, but for this, because this is a pth root of x power n, so I think okay, I think here we don't take they don't ask any particular value for fourth problem. Okay, to find the particular value only we need x naught value. So here they are asking only iterative formula. Okay, for the fourth problem we don't have any problem here because they don't ask hence find anything. But only in the third problem, second and third problem, second problem is solved, but the third problem you should take x naught equal to 25 power 1 by 3. So there is no other option for me because that is very close to 24 power 1 by 3. But fourth problem, just we should find the pth root of positive number n. So they don't ask any particular value, so that's why we don't bother about x naught. Is it okay, Nagesh?
No, sir. Okay, sir.
Okay, I think so this is okay. Next method is I will check it, the syllabus. I still have 7 more minutes. Okay, so I will start the next method. Okay, iteration method. So the next method is iteration method. Or method of successive approximation. Or method of successive approximation. Method of successive approximation. Okay. So just I will tell the procedure and the condition in this class. Okay, if possible, I will try to solve one problem. Okay. So first I will tell the procedure. Suppose we want to find the approximate root of the equation f of x is equal to 0. Okay, so we should write like this. Suppose we want to find the approximate root of the equation f of x is equal to 0. Because this is equation 1. So write the equation in the form x is equal to some function phi of x. X is equal to phi of x. This is equation number 2. Okay. Now Assume x naught be the starting approximate value to the actual root alpha. Okay, assume x naught be the starting approximate value value to the actual root alpha of x is equal to phi of x. Okay. Now let us take x is equal to x naught in the right hand side of equation 2. The RHS of equation 2, we get the first approximation. So that is x1 equal to phi of x naught. So now again take x1, x is equal to x1 on the right hand side of equation 2. You'll get x2 is equal to phi of x1. Similarly, it should go x3 equal to phi of x2. So finally, xn equal to phi of xn minus 1. Okay, the sequence of approximate roots x1, x2, x3, x4 up to xn. If it converges to alpha, okay, if it converges to alpha, is taken as the root of the equation f of x is equal to 0. Okay, so this is a procedure. Okay, so but we don't go for up to n. Okay, I think up to 6 iteration or 7 iteration. Sometimes it will take 10 iteration. Okay, because the right hand side value should repeat at least for 4 decimal places. So then you can stop the iteration. So here note, the convergence of the sequence is not guaranteed always unless the choice of x naught is properly chosen. That is, x naught is the approximate value. Okay, so if you don't choose properly the approximate initial value x naught, you will not get the answer immediately. So the convergence of, I'll write here, note 1. Convergence of the sequence is not guaranteed. Not guaranteed always unless the choice of x naught is properly chosen. So next note. The convergence is linear and the convergence is of order 1. So the convergence of this method, okay, the convergence.
Excuse me, sir.
Yeah, please tell.
We have another class now.
Oh, okay. I think time is over. Huh? Okay, yes, over. Okay, we'll meet tomorrow. Thank you.